Hello, this is part 2 of section 7.2. And we're going to start with example 1. So find the equation of the parabolas graphed below. So for part A, with everything labeled as it is, it's very easy. I'm just going to find what the vertex is. 1, 2, 3, 4, 5. 1, 2, 3. So the vertex is 5, 3. And then P is the distance between these 2 points, which is 1, 2, 3, 4. So that means our formula, and because it opens left, this is horizontal. Let me just write it there, because it opens to the left. That means our equation is y minus k squared equals 4px minus h, where k is 3, so we get y minus 3 squared. P is 4, so 4 times 4 is 16. And then h is 5. So there's the equation of our parabola. So when you're given the focus, vertex, and directrix, it's not that hard to find the equation. In part B, it gets a little bit more difficult. Well, we still do have the vertex, even though they didn't definitively put a point there, we still have -2, 1. But this time, because we do not have the focus or directrix, you just need a second point on the parabola. Now, I'm going to choose the second point of -1, 2. Well, now and because this is vertical, I know it's x minus h squared equals 4p y minus k. H is -2, so it's x plus 2 squared equals 4p y minus 1. Now, in order to find p, you have to plug your second point. So -1 in for x. Two in for y. And solve. So we get 1 squared equals 4p times 1. 1 equals 4p. Actually, I'm going to show you a trick here. You could go through and solve for p and get p is equal to 1/4. But my equation, I want to know what 4p is. Well, this equation says 4p equals 1. So that means I'm just going to replace 4p by 1. So we get x plus 2 squared equals 1 times y minus 1. And of course, you don't actually have to write the 1 there. Example 2, find the equation in the standard form of a parabola with the given properties. So when I'm given the properties instead of the graph of it, I actually do just sketch a graph of it. So I know the y-axis is my directrix. So draw my directrix. There's my x-axis. -4, 2 is about right there. Well, since the directrix is a vertical line, this is going to be a horizontal parabola. So y minus k squared equals 4px minus h, because the parabola is always perpendicular to the directrix. Then also, because the vertex is halfway between the focus and the directrix, I know my vertex is going to be at -2, 2. So that means we get y minus 2 squared equals 4px plus 2. And then finally, p is the distance between these, which is 2, but since it's going to the left, it's -2. So we get y minus 2 squared equals 4 times -2x plus 2. Or y minus 2 squared equals -8 x plus 2. And I'm going to clarify the reason why I know it's opening to the left is because the parabola always hugs the focus, or it shies away from the directrix, whichever way you want to look at it. So there's the equation of this parabola. Now part B, we have the vertex of -8, -9, and then 2 points that are on the curve. Again, I'm going to sketch where these points are. Let's just say right there. So I know this is a vertical parabola. So that means it's going to be x minus h squared equals 4p y minus k. Well, we already know the vertex, so x plus 8 squared equals 4p y plus 9. Now again, because I don't know where the focus or the directrix is, I need to use a second point on the line. I'm just going to use 0, 0. So 0 plus 8 is 8 squared equals 4p times 9. So 64 equals 4p times 9. Divide by 9 on both sides. We get that 4p equals 64 over 9. Again, you could solve for p, but since the formula does have 4p in it, I'm going to stop here. And then our equation is x plus 8 squared equals 64 over 9 y plus 9. Now, instead of giving you a graph or information about the parabola, I'm going to actually give you the equation of the parabola, but I want you to put it in standard form. Standard form for this section are the two formulas in the notes, not vertex form or ax squared plus bx plus c. So the first thing I'm going to do is identify the squared variable. So it's y squared, which means this is horizontal. If it's horizontal, you want to get the y's by themselves. So I'm going to subtract the 4x and subtract the 211 over 4 from both sides. So we get 3y squared minus 27y equals -4x minus 211 over 4. Once you get the squared variable by itself, the next thing you have to do is complete the square with respect to that variable. So in this case, to complete the square, I need to get rid of the 3. So I'm going to multiply both sides of the equation by 1/3. So we get y squared minus 9y equals -4/3 x minus 211 over 12. Next, you take half of b squared. So that's -9/2 squared, which is 81/4. So I'm going to add 81/4 to both sides. Now y squared minus 9y plus 81/4 is a perfect square trinomial, and it factors into y minus 9/2 squared. And then on this side, I'm just going to add those fractions together, and actually it comes out to be 8/3. Then after you completed the square, you are going to factor out the coefficient on the non-squared side. So that means I need to factor out that -4/3. And when factoring is the same thing as division, so the reason why it's -2 is because I did 8/3 divided by -4/3. So keep, change, flip. The 3's cancel out, the 4 makes the 8 a 2, and the negative is a negative. So that's why it's -2 right there. Let me get rid of that though, that's just scratch work. Now this technically is the answer. I am going to go one step further by factoring a 4 out. So we get 4 times -1/3 x minus 2. So then the vertex is 2 comma 9/2. And the reason why I factored that 4 out is because then it's obvious that p is -1/3. Now for part B, we're going to do something very similar. Because it's x squared this time, that means it's vertical. So I'm going to subtract the 12y and subtract the 1. So we get x squared minus 10x equals negative 12y minus 1. There is no leading coefficient, so I get to jump straight to the 1/2 of b squared, which is negative 5 squared, which is 25. So I'm going to add 25 to both sides. This factors into x minus 5 squared. This becomes negative 12y plus 24. Factor that negative 12 out. Factor that 4 out again. Again, this isn't part of the directions. I'm doing this as an extra part so I can identify what P is. So our vertex is 5, 2, and P is negative 3. Okay. Normally I would call this video good because I'm past 10 minutes, but I only have 2 more problems to do, so I'm going to just make this video a little longer than usual. So now how do we graph it? Well, if it's in standard form, it's not too bad to graph. First of all, since it's y squared, that means this is horizontal. It's in standard form, so I can see that the vertex is negative 1, 2. And then 4p is equal to 12, because that's what's in front of the x plus 1, which implies that p is equal to 3. So going through and graphing it, I get negative 1, 2 is the vertex, which is right there. Since this is horizontal and p is 3, that means I'm going to go 3 to the right from the vertex. 1, 2, 3. Now, there's many ways to graph this, but this is why I like the focal diameter. It makes it very easy to graph it. Once you identify where the focus would be, then you go 2 times p up and 2 times p down. So 2 times 3 is 6. So I'm going to go up 6. There's 1 point on my parabola, and I'm going to go down 6. And there's a second point on my parabola, and we go ahead and connect these 3 points in a U shape. And there's our parabola. And just for fun, I know the directrix is right here because it's 3 units in the opposite direction. And again, the focal diameter and the directrix should be parallel, which they are. Now for part B, I'm hoping you realize it's the same as part B in example 3. So that means we've already simplified this to x minus 5 squared equals negative 12y minus 2. So since it's x squared, this is vertical. The vertex is 5, 2, and we already identified p as negative 3. So 1, 2, 3, 4, 5, 2. And since it's vertical and p is negative 3, I'm going to go down 3. 1, 2, 3. And then 1, 2, 3, 4, 5, 6. The reason for 6 is you go 2 times the absolute value of p. 1, 2, 3, 4, 5, 6. Connect these in a U shape. And again, the directrix is 3 in the other direction. So there's our directrix, and again, it's parallel to our focal diameter. And that is it for section 7.2 notes.